So how do we factor a trinomial that is not a perfect square? Well, first we just have to make sure that it is in the form x squared plus bx plus c, but any trinomial in that form we can factor. Our step one is to break down the c into factors. So any factor of 2, but the only factors of 2 are 2 and 1. And now what we need to do is we need to write a factored form, x, and we need to find a combination of these factors that will add up to our b value, because we already know they multiply to equal our c value, so we will just need them to add up to our b value. But luckily, 2 plus 1 is equal to 3, so we can just do x plus 2 times x plus 1, and this is our solution. But let's go ahead and check it just to make sure. Check x plus 2 times x plus 1. So x times x is x squared plus 2 times x, and then plus 1x, and then we have plus 2. Let's combine like terms, and that gives us x squared plus 3x plus 2, which gives us our original expression. So once again, we found all the factors of 2, and then we put the problem in a factored form that if we multiplied it back out, the factors would multiply to the c, and they would add up to the b. And that is how we factor trinomials that are not a perfect square. This might be a little difficult at first, but eventually you'll be able to just look at a trinomial and factor it in your head. But until then, let's do a couple more practice problems. So this example, we can see it's already in the form x squared plus bx plus c, x squared plus 4x minus 32. Yep. So we're just going to start by finding the factors of our c, which is 32, or negative 32 technically, but 32 times 1. And then we can also do 16 times 2. And then we can also do 8 times 4. And then what else can we do? I think that's it for breaking it into factors of 2, but let's go ahead and write it out in factored form. So now we just need to find which set of factors will add up to 4. 32 and 1 will not. 16 and 2 will not. 8 and 4, they can. So if we subtracted 4 from 8, that would give us 4. And that would give us positive 4, actually. And that would also give us 1 negative sign and 1 positive sign, which, if we multiplied those together, they would give us a negative 32. So that is actually our solution. So we can just write this as x plus 8 times x minus 4. Once again, if you want to check it for yourself, feel free, but I know this is the correct solution. And so we just followed the simple steps. We just found the factors of 32, 2 factors, and then we saw which ones would add up to give us our b value, and then we just found the appropriate signs that would give us this and multiply to our c value. In this example, we can actually factor it using the same method as we just factored our last few examples. If you look, we have over here in our bx, our x is an x squared, which would be a problem, but over here we have x to the power of 4, which is x squared squared. Let me just write it to show you. So if you look, you have a something here, and then a something squared. And that is how we're able to factor it, because we have our x squared minus some b value times x, and then plus some c value. So we're able to factor it just like we normally would. We just have to take into account that our x has become x squared. So step 1, let's find sets of 2 factors of 45 y to the power of 4. We're just going to break up y to the power of 2 into each factor, because y to the power of 2 times y to the power of 2 is y to the power of 4. So we can do 45 y squared times y squared. That's one set of factors. We can also do 15 times 3 is also a factor. So we can do 15 y squared times 3 y squared. And we can also do 9 times 5, because 9 times 5 is 45. So 9y squared times 5y squared. And I'll say it again here. This is why it's important to have your multiplication tables memorized, because manually trying to figure out what the factors of 45 are, if you didn't have it memorized, would take a lot more time. So if you still haven't have your multiplication memorized, you might want to do that right now. But let's go ahead and go to the next step. What can add up to equal 14? Can 45 and 1? No. Can 15 and 3? Nope. Because that'll give us either 12 or 18. 9 and 5? Yes, because 9 plus 5 is 14, and negative 9, negative 5 gives us negative 14. So let's go ahead and write this in factored form. Remember, what is our x? It's just x squared. So when we write it in factored form, we just have to write the x squared instead of x, because that is our normal x is x squared. And let's write our factors here, and we know they're both 9, because negative 9, negative 5 is negative 14, and negative 9 times negative 5 is positive 45. So we can write it as x squared minus 9y squared times x squared minus 5y squared. And then if you want, you can just multiply it all out just to check it, but that is the solution for this example.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.